Hello everyone. In this video I am going to discuss regarding the factors that's coming on the grade 4, 5, 6 and more. Mostly we have learned about the tables. We start about the tables on grade 2, 3, 4 something like that. That is mostly important when we start in our factors. You should have a better idea about the tables. In the factors, let's see, first of all I already have created some tables. That's 2 table, 3 tables, 4 table and 5 tables. 2 times 1 is 2. All the things we know about that. The 4 tables we know. All the things we know about that one. So let's think something. I am going to take a number from this one. I am going to take a number. I will take number 24. I will take number 24. I will take number 24. 24. So what are the ways, what are the tables that I can find this 24? I can find 24 in 2 tables. Of course I can find it. I can find 24 in 2 tables. 2 times 12 is 24. Is 24. You also can find in 3 tables. It's 3 times 8 is 24. Again I can find it's on 4 table. Even I can find it's 4 times 6 is 24. Something else, yes, I can find it's on 6 table. Yes, 6 times 4 is also 24. Like that I can find this number. So 20 is a number, but it is called different tables. What's that mean? So what are the possible ways I can make this 24? That is referred to the factors. Now I will write down something here. That means 24 I am going to make it. 24 is the number I am going to make. I am going to make number 24. The number. I can find this 24 in many tables. 2 times 12. So also we got 3 times 8. 4 times 6. 6 times 4. As well as it's coming also in 8 times 3. And 12 times 2. 12 times 2. As well as it is also in 1 table. 1 times 24 is also 24. 24 times 1 is also 24. So that means I can make this 24 with different ways. So I will write down it as something like this now. Yes, 24. What are the possible ways I can make it? It is coming with 1 and 24. 1 and 24. It's coming with the 1 and 24. It's coming with the pairs. 1 and 24. It's a pair. 1 times 24 and 24 times 1. It's also equal to 24. Second, I can take it in 2 table. 2 times 12. 2 times 12 is 24. I am writing it as second pair is 2 times 12. 2 times 12. Third pair is I can take it in 3 tables. 3 times 8. 3 tables, 3 times 8. It's coming with a pair. Again I can get it in 4 table. 4 times 6. We got it here. 4 times 6, 6 times 4. 4 times 6. It's 24. We got that one. Is there any number between these two? Yes, there's only 5. 5. Can I find 24 in 5 table? No, it's not possible. It's not there. It's not there. 24 is on 5 table. That means I can't get. What are the total factors? These are called total factors. These are called 1, 2, 3, 4, 6, 8, 12 and 24 are the total factors. This method is called total factorization. Write down that word. It's called total factors of 24. This is the way. Everything that I can build 24 is here. How many factors are there? There are 1, 2, 3, 4, 5, 6, 7, 8 factors. There are 8 factors. There are 8 factors. There are 8 factors that I can make 24. Now let's take another number. I will scroll it down and take one number. I'm going to take it now 36 now. I'm going to take 36. Okay, I will take 36. 36. 36. What are the possible ways? And start in the bracket and close in the bracket. I am going to write down all the factors that I can build 36. It is coming on. First we have to write down 1 and itself. 1 and itself. 1 and 36. 1 times 36 and 36 times 1. That means it is coming with, I will use it and write down here. It's coming with one pair, that is 1 and 36. It's a one pair. Second pair, is it on 2 table? Yes, it is divisible by 2. That is, it is coming on 2 times. I am going to divide now 36. I am going to divide it by 2. It is divisible by y. It is ending with 2. 1 is coming here. 3 divided by 2 is 1. Again multiply, it's coming 2. Subtract, it's getting 1. 16. 16 divided by, let's move it down 16. 16 divided by this, it is 8. 16 and let's use, that means r is equal to 0. That means it is on 2 table. 2 times, and this is coming on 2 table. 2 times 18 is 36. Is it on 3 table? 36. Is it divisible by 3? Yes, of course it is divisible by 3. It is coming. 3 plus 6 is 9. 9 is divisible, so it is on 3 table. It's on 3 table. 3 times. 3 times. What's coming? 3 times 12 is 36. Is it on 4 table? Yes, of course. 4 times 9 is 36. Is it on 5 table? No, it is not ending with 5. It is ending with 6. It is not in 5 table. It's not in 5 table. That means it's not in 5 table. It's not in 5 table. Next, is it on 6 table? Yes, 6 times 6. 6 times 6. So we are not writing same number again at here. We are not writing this one again. Why? We already have included that 6. That means I won't erase this one. I already have included that one. So what are the pairs coming? Second is 2. 2 times 18. Third is 3. 3 times 12. Fourth is 4. 4 times 9. Last one is coming 6 times 6. All these are coming with pairs. All these are coming with pairs. So how many factors are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 factors. There are 9 factors. There are 9 factors. That means I can build 36 using these digits. Using these. These are tables that I can find 36. These are the pairs of factors. Pairs. It's coming with the pair. This is another example for 36. There are another one that is called this method is called factorization. Total factors. Here we are calculating the total factors. Total factors. Total factors. Total factors. It's called total factors. There's another method that is called factor tree. Now let's go and see what's meant by factor tree. I go for new page. Here I am going to discuss about the factor tree. Factor tree. It is just like a tree. It is just like a tree. It is just like a tree. I am starting with a number. I am trying to find how they can have these branches. I will take one number now. I will take 36. Yes, I will take 36. 36 I can find in 6 table. I am taking 6. That means 6 times 6 is 36. First of all, I will erase these things and next I will try to join it now. 36 I can find in 6 table. That is 6 times 6 is 36. Next, I am going to make the possible ways how this 6 can make. 6 can make with 2 times 3. Yes, it's coming 2 times 3. Again, this 6 also coming 2 times 3. 2 times 3. Is there any way to build 2? That is only 2 times 1. 3 is also 2 times 1. Is 2 also. That means these are the ends. These are the ends of the tree. These are the ends of the tree. Ends of the tree. If I cut this one and turn to the other side, it is just like a tree. That is why it is called as factor tree. That means I am making 36. How can I make it? What are the numbers I am ending? It is ending with 2 and 3 and 2 and 3. And I can write down these are the numbers that's end. All these numbers are prime numbers. Prime numbers. In the next lesson we are learning what are the prime numbers. At that time we will learn what are prime numbers. Factor trees are always ending with the prime numbers. It is very important to understand what are the factors, why it is also used in different ways. If you want to divide a big number, this is also important to know what are the factors and how can I use this factor to minimize or simplify the division. Now let's see another number, and I will scroll it down and take one number. Let's see another number. I will take number 24. 24. I am going to draw the factor tree for the 24. 24 is the number. In which table I can find? You can start it any way. You can start it any way. Here I will do it in 2 different ways. Here I am starting with 24. Here I am also starting 24. Same number I am doing, but with 2 different ways. 2 different ways. Here also 24. 24 I can find it 4 times 6. Yes. Here I am doing it 8 times 3. It's also same. Here 4 times 6 also. 4 times 6 is 24. 8 times 3 is also 24. Both are getting 24. 24. Now I am going to extend my tree. What are the other branches which come for the 2? 4. Yes, there are 2 branches for the 4. 4 is built in with 2 times 2. 6 is built in with 2 times 3. 2 times 3. Are there any branches for this? 2 is only built with 2 times 1. So 2 is a prime number. This 2 is also prime number. This 3 is also prime number. That means I already finished on this tree. This tree I already finished. Next I am going to the next tree. 3 it's only a prime number, so it is not going to divide again. It is 3 times 1 and 1 times 3. That's already finished. Next I am going for this 8. 8 and can make with 4 times 2. 2. This 2 is already finished now. This one. So I will draw it again. It's 2. It's already finished now. This 2 is already finished. But this 4 I can make it further. I can further break it. How can I further divide 4? It's coming 2 times 2. 2 times 2. So what are the n numbers of this tree? I will take another color and mark. This is the 1 n number. This is the second n number. This is the third n number. This is the fourth n number. These are the n branches, ends of this tree. What are the 2 and 2 and 2 and 3? I start with different way. Why? But in these two cases, I end with same. End with same. That is the beauty. Although we start in different ways, we are ending with same. 2, 2, 2 and 3. 2, 2, 2 and 3. That means 24 is equal to 2 times 2 times 2 times 3. This method is called factor tree. Factor tree. Now let's see by getting two numbers and try to write down their factors. Try to write down their factors and compare these factors with each another. I will go for another page. Previous page. At the first page, we discussed regarding the factors and what are the tables what we know. From that one, we write down all the factors that we can build this 24. What are the ways we can build? Next, we done another example for 36. What are the possible ways we can make 36? All these are coming with pairs. And how many factors are there? We can count it, and there are number of numbers. When you go to the second page, I discuss factor tree. It's also very, very important part. It's a factor tree. How we can build these numbers? They are always end with prime numbers. That means 36 is built in 2 times 3 times 2 times 3. Normally we are writing in the same order: 2 times 2 times 3 times 3. This is very important to understand. In future we will learn that one. How to understand a square number, whether number is square or not. It's also coming making the factor tree. Lastly, we done 24. So we've done it in two different ways. Start the numbers and we done it as we wish. What are the tables I can find? But it is ending with same. That's the thing. Now we are going to do something with two numbers. I will write down the factors for 24 and 36. I am going to write down the total factors. Factors are limited, so that is why we are enclose it. We are going to write down enclose. It is start and end. Why? We have a limited number of factors, not like the multiples. Multiples are infinite number of. It's not ending. It's infinite number. But factors, we have limited numbers. Only maybe 2 factors, maybe 5 factors, something like that. Now I am going to write down the factors for 24. Same thing we done previously. 1 and itself. Second, it is on the 2 table. 2 times 12 is 24. Third, it is coming on the 3 table. Why it is divisible by 3? 3 times something, 3 times 8 is 24. Next, it is on the 4 table. 4 times what's coming? 4 times 6 is 24. Here only 4 and 6. That means only one number is remaining. That's 5. This 5 is not in 24 is not in 5 table. This here we got all the factors. That's called total factors. Here total factors. Now I am going to write down the factors for 36. 1 and 36. Second, it is also in 2 table. Why it is divisible by 2? It is on 2 tables. 2 times 18. 2 times 18. Next, it is also in 3 table. 3 times what's coming? 3 times 12. Next, it is on 4 table. 4 times 9 is 36. It is not in 5 table. Why it is ending with 6? Is it on 6 table? Yes, also 6 table. 6 times 6, but we are not writing same number again and again. Just we are writing only one. This is the total factors. here also total factors. Total factors. Now I am going to mark what are the common factors for them. Common. I am going to write down these are the numbers I consider 24 and 36. I am going to write down common factors. Common. Common for both. Sometimes maybe 3 numbers, 4 numbers. Now here we have only 2 numbers. Now I am going to mark common for both. What are the common factors for both? Let's see now. 1 and 1 is there. Yes, 1 and 1 is there. 2, here also got, here also you got 2. Here you got 3, here also you got 3. Here also you got 4, here also you got 4. Here you got 6 and here also got 6. Here 9, but 9 is not there. Here 12, 12 is there and 12 is also there. 18, not 18 there. 36, 36 not there. What are the common factors? 1 is a common factor, 2 is a common factor, 3 is a common factor, 4 is a common factor, 6 is a common factor and 12. It is also limited. Have the limited numbers. Limited numbers. Limited. That means it is not infinite. It is not infinite. Not infinite. It's a limited. It's also here also limited. We have some limited number of factors. Limited number. So 1 is always factor for all. Factor for all. All. But there is a highest value for that one. Highest value. This is something highest for highest factor for 24 and 36. What's that one? That is 12. There must be a special name for that one. We don't have a minimum value. Minimum value is always 1. But maximum value is different from number to number. If you taking another number, maybe it's maybe different. Here we got the maximum value. That's called highest. In other words, we can say it is a factor for both highest as well as it is common. Highest common factor. It is the highest common factor for both 24 and 36. So that is how we can find highest common factor. So we will take another example. Now let's take. We also can mark this one in chart even for the diagrams. I'm going to draw diagram. This is the factors for 36. This is the factors for 24. It's the factors for 36. 36 factors for 36. Something is here is common. Here this area is common for both. This area is common for both. So what are the common factors I can find? 1 is there, 2 is there, 3 is there, 4 is there, 6 is there and 12. These are the common factors. Common. This one is common. Common for both. So what are the other factors? That's only belongs to this only for 24. This one is only for 36. Only for 36. So what are the things that's only for 36? Here when I come for 24, these things I already have taken. This one already have taken. 8 and 24 is not selected here. That is only for 24. It is not in here. So it's not in 36. That is 8 and 24. I can write down 8 and 24. Next go for the 36. This one is already taken. That's common. This is common. This is common. This is common. This is common. 9 is not there. 12 already have taken. 9, 18 and 36. 9, 18 and 36. 9 is there. 18 is there. And 36. These numbers are only factors for 36. These numbers are only factors for 8. These numbers are 1, 2, 3, 4, 6, 12. These are common for both, common for both 24 and 36. Common factors, common factors. So 12 is very special, that is the highest one. It's called highest common factor. This is the how we can do it in grade 6, how to find common factor for numbers. Now let's see for 3 numbers. I will take another example for 3 numbers. I am going to take a one. I will take 25 and 20 and 80. I am going to write down the factors for this. It is limited, that is why I am going to close. This is limited. It is not going to be infinite. It is limited, that is why I can close this bracket. It's limited. What are the factors? It is coming with the 1 table and 25. 1 and 25. It's coming automatically. Next, it is on 2 table? No. Is it on 3 table? No. It's on 4 table? No. Why it is ending with 5? It is on 5 table. 5 times 5. No, I don't want to write down same number again and same number. It's not possible to write down like that. If it is 5, we are not possible to write down 5 to the other side. That means only how many factors are there? There are 3 factors. For this number, there are 3 factors. Now, write down for 20. In 1 table, I can find 1 and 20. Next one, I can find it on 2 table. Yes, I can find it 2 times 10 is 20. Is it on 3 table? No, it is ending with, if I add these 2, it's getting 2. So it is not in 3 table, it is only. Next I can go for the 4 table, is 4 times 5 is coming. 4 and 5, that means closed. This is closed, this gap is closed, this is 4, this is 5, it is closed. That means we don't have anything. I am going for the 18. 1 is there, 1 and 18. This is the first factor I can write down. Here I got 1, 2, 3, 4, 5, 6 factors. 6 factors. 1 and 18. Next it's coming on 2 table. Yes, of course. 2 and 9. 2 times 9. Is it on 3 table? Yes, of course. 3 times 6 is there. Is it on 4 table? No. 18 is not 4 table. 16 is there. No. 16, 20. Is it on 5 table? No. It's again come to 6. That means I already closed. There are no any other factor between 3 and 6. Let us call. That means I already have what are the factors? 1, 2, 3, 6, 9, 18. These are the factors. How many factors are there? There are 6 factors. 6 factors. So there are 3 numbers. So I am trying to find the common for these 3. What are the common? Common for 25, 20 and 80. 1 is there. Here also 1 is there. 1 is there. Common factors. It is also limited. It's also limited. This is also limited. It is not going to be infinite. It's a limited. Limited. 1 is there. Other side is coming. Second one, is it 2 is here? 2 is here, but not there. 3 is here. 3 is here, but not other. 6 is here. 6 is not there. 9 is here. That means we don't have any other factor rather than this one. That's the common factors. Is there any other common factor for these things? No, we don't have anything that is common rather than 1. We don't have any other. That means that 1 is the only common factor for 20, 25 and 80. What is the only factor that's coming for these numbers? So what is the highest common factor for this? That's already 1. 1 is the only factor for these things. Okay, next I will come with another way of finding the HCF, highest common factor, and what are the practical problems we can find in why we are finding this HCF and what is the useful of it. We will discuss in next video. Thank you very much for watching this video.